Yeah, hello, welcome to the solutions of practice assignment 4 of statistics 2. Uh, let's start with the first question. The probability density function of a continuous random variable x is shown in the figure. All right. So the probability density function of the graph is given, and this is the question. Okay, so they have given the function as e to the power of minus x wherever x is greater than or equal to 0, and rest everywhere it is 0, right? So this is what it is, and we have to find probability of x less than 0 and it is greater than minus epsilon, where uh, epsilon is a very small positive number. So in the graph or in the function we can know that whenever x is less than 0 it is always 0. So this probability will be obviously 0. Just by looking at the graph we can always say that from 0 itself the value is whenever the small x is 0 and the probability is 0 everywhere. So this epsilon is a very small positive number, which is less a very small positive number, right? So we are talking about x which is greater than minus epsilon. Minus epsilon is somewhere here. It will be somewhere here, and obviously the x will be lesser than 0, and therefore the probability itself will also be 0, right? So next question. Which of the following statements is or are true for a continuous random variable with PDF fx of x? Okay, the first option is, okay, the first two options looks very similar, but the only difference is the first option we have equal sign and second option we have approximately equal to sign. Okay, so now we can write this as probability of 1 minus epsilon, which is less than x, and that is less than 1 plus epsilon, is proportional to what? Fx of 1. Okay, now probability of, let's say, 2 minus epsilon less than x less than 2 plus epsilon will be proportional to what? It will be proportional to fx of 2. As you can see that these two are not linear, right? So as we can see, any probability, it can follow any probability distribution, so we cannot say that these are linear. So now if now 2 fx of 1 is equal to fx of 2, let's say, then what will happen? It means that this probability function 2 minus epsilon less than x and it's less than 2 plus epsilon will be approximately equal to 2 into probability of 1 minus epsilon less than x and less than 1 plus epsilon. Why? Because these are not linear, and it will be approximately equal, it will not be definitely equal, right? So the second option is true. Now what about third option? So they are talking about at a single particular point. So we know that at any instant or any one particular point, continuous random variable, the probability will be 0. Okay, so now the last option, CD of fx of x is continuous in the domain minus infinity comma infinity. Yes, we also know that this is true. Now next question. So they have given a function. What is the value of probability x less than or equal to 4? Enter the correct answer to 1 decimal accuracy. Okay, so they have given us a hint to use this particular integration formula. So now how to do this? They have asked us to find out the probability for x less than or equal to 4. So this comes under this domain. So we have to find out probability of x less than or equal to 4, which is nothing but integral minus infinity to 4 fx of x dx. So now that can be in turn written as minus infinity, and this starts from 1, minus infinity to 1 fx of x dx plus integral 1 to 4 fx of x dx. So we know that this function is 0, right? So this is nothing but integral 1 to 4 1 by 18 into x square minus 8x plus 16 dx. Now which is nothing but I'll just take 1 by 18 outside, and now I'll integrate. What will happen? X square integration is x cube divided by 3 minus 8. Integration is x square divided by 2 plus 16 integration is 16 x. What are the limits? 1 to 4. Okay, and now this is nothing but 1 by 18 into, if I substitute this, what will happen? (63 by 3 minus 4 into 15 plus 16 into 3). Now this is nothing but 1 by 18 of 21 minus 60 plus 48, which is nothing but 9 by 18, that is equal to 1 by 2. Okay, now moving on to the next question. We have, if x is normal 10 comma 25, what is the value of expectation of 2x square? Okay, so now given that this is mu and this is sigma square, okay, we know that, so we have to find out expected value of x square first. So that is nothing but variance of x plus expectation of x the whole square, right? So this is nothing but variance is 25 plus expectation of x is 10 whole square, that is 100. 100 plus 25 is 125. Okay, so now expected value of 2x square is nothing but 2 into expected value of x square. Now that is nothing but 2 into 125, which is nothing but 250. Okay, fifth question. If x is normal of 10 comma 4, then what is the value of probability x greater than or equal to 8 given x is less than or equal to 9? Use the standard normal distribution tables if necessary, and they have given some values here. Now we'll start with the question. So the given probability is probability of x greater than or equal to 8 given x is less than or equal to 9. So this is nothing but probability of x greater than or equal to 8 intersection of x less than or equal to 9 whole divided by probability x less than or equal to 9. So this is in turn fx of 9 minus fx of 8 whole divided by fx of 9. Okay, so now for converting normal distribution to standard distribution, so we'll have for x equal to 8, let's say, and now z, now that is equal to, let's say, x minus mu divided by sigma, and now that is nothing but x is 8 minus 10 divided by sigma is square root of 4, that is 2. Now that is nothing but minus 1. And for x equal to 9, we have z is equal to 9 minus 10 divided by 2, that is nothing but minus 1 by 2. Now fx of 8 is nothing but fz of minus 1, and fx of capital X, fx of 9 is nothing but standard distribution fz of minus 1 by 2. Okay, so therefore probability of x greater than or equal to 8 given x less than or equal to 9 is nothing but, and they have given all these values, right? So fx of 9 is nothing but fz of minus half, that is this particular value, that is 0.30854 minus 0.15866 whole divided by 0.30854, and which is nothing but 0.486486. Right, so next question. So they have given a random variable x which have the following PDF. So they've given a function the range of the x is 0 to 1. Okay, so define y is e to the power of x. What is the PDF of f y of y? Okay, so they've asked us to find out the PMF of y. Okay, so how to do this? So we know that y is equal to, let's say this is a function of x, right? So I'll talk about g of x, where g of x is any function of the random variable x, and that is nothing but e to the power of x. Okay, I'll now take log on both sides. What will happen? I'll get log y is equal to this is nothing but x. Okay, so now separately, if I and now what is this log y? Log y is nothing but g inverse of x, right? So this is no differentiation, this is inverse of x, g inverse of x, sorry, g inverse of y. This is not x, this is y. Okay, so now what is g of x? G of x is nothing but e to the power of x. And now this implies that g of x is e to the power of x. So we already know this. Now what is fy of y? Now that is nothing but 1 over modulus of g dash of g inverse of y, okay, into fx of g inverse of y. Now how do we solve this? 1 over modulus of g dash of, what is this g inverse of y? G inverse of y is nothing but log y, that is log y into what is fx of g inverse of y is log y, and now that is nothing but 1 over what is g dash of y? G dash of y is nothing but e to the power of y, right? So g dash of x, what is this? G dash of x is nothing but e to the power of x. Okay, so what is this? E to the power of log y into what is fx of log y? That is nothing but 2 log y. Okay, so this is nothing but 1 over y into 2 log y. Okay, that is the first option. Right, so moving on to the next question. So they've given a CDF of a random variable. So we have the CDF, and now we have to find out which of these statements are correct. Okay, so now we have given a CDF, we have to find out the PMF, right? So how to do this? We have to differentiate this all around. So what is the formula? Fx of x is nothing but d by dx of fx of x, right? So how to do this? So now we can write this. Fx of x is nothing but d by dx of first term, that is 0. What is the range for this? X is less than or equal to 0. So what is the differentiation of second one? D by dx of 2x square, the range is 0, less than or equal to x, and less than or equal to half. The next one, d by dx of half. The next one is d by dx of x by 2. Next, d by dx of 1. So the ranges are half, less than or equal to x, and less than or equal to 1, 1 less than or equal to x, and less than or equal to 2, and x greater than or equal to 2. And now this implies that what will be the function now? This differentiation of 0 is 0, differentiation of 2x square is 4x. Now this is 0, and this is 1 by 2, and again 0. Right, so the ranges are same as above. So as we can see that fx of x is continuous in the domain, right? So therefore x is a continuous random variable. So how can we say that continuous? So obviously with the help of this function, so there is no infinity or infinity involved here, so we can say that this is a continuous random variable. So obviously we cannot say this as a discrete random variable because it is not taking a individual value, right? Okay, so next question. So by looking into these things, we can say that these are not the PMF of the particular given CDF. Okay. So next question, what is the value of probability x greater than or equal to 1 given x is less than or equal to 1.5? So we can write the given conditional probability as probability of x greater than or equal to 1 intersection x less than or equal to 1.5 whole divided by probability of x less than or equal to 1.5, and now which is nothing but f x of 1.5 minus fx of 1 whole divided by fx of 1.5. So which is nothing but 1.5 by 2 minus 1 by 2 divided by 1.5 by 2, which is equal to 1 by 4 by 3 by 4, which is equal to 1 by 3. Okay, next question. The time taken by Rohit to complete a race follows a exponential distribution with expected time of completion of 10 minutes. So what is the expected value of x? That is 10 minutes. And now what is the probability that Rohit takes less than 20 minutes but more than 10 minutes to complete the race? Enter the answer up to 2 decimal accuracy. Okay, so now for an exponential distribution, what is the formula for expected value of x? That is 1 by lambda. So 1 by lambda is equal to 10. So what is lambda is equal to 0.1. Okay, for exponential distribution, we know that the cumulative distribution is fx of x is nothing but 1 minus e to the power of minus lambda x. And now probability of x greater than 10 is equal to 1 minus e to the power of minus 0.1 into 10, and now that is nothing but 1 minus e to the power minus 1. And now what is probability of x greater than 20? Now that is nothing but 1 minus e to the power of minus 0.1 into 20, which is nothing but 1 minus e to the power minus 2. Now what is probability of 10 less than x and less than 20, which is nothing but fx of 20 minus fx of 10, which is nothing but 1 minus e to the power of minus 2 minus 1 minus e to the power minus 1. So which is nothing but, if I take out the brackets, I'll have 1 minus e to the power minus 2 minus 1 plus e to the power minus 1. Plus 1 and minus 1 is cancelled. So what is remaining? E to the power of minus 1 minus e to the power of minus 2. And if you substitute the value of e, we'll have 0.232 as the answer. Okay, so now 10th question, the PDFs of random variables x1, x2, x3, x4, and we have 5 different PDFs given. We have to choose which of these are true. Okay, so for a normal distribution, so by looking at the graph, these are all normal distribution, right? So they've given that this is a normal distribution. So what are the characteristics of normal distribution? Wherever we have the mean, we'll get a peak. Okay, so now we have the mean of the first x1 is here. Let's say expected value of x1 is minus 10. Okay, assuming that I have read the graph correctly. And what about x2 is 0. Expected value of x2 or the mean is 0. And now what about x3? x3 it is around 20. Now x4 is around 10. And now what about fifth one? Fifth one is, it is again around -10. Now by looking into this, x1 is approximately equal to x5. Yes, correct. And what about this x5, that is -10, is less than expected value of x2? Yes, this is again true. And now what about expected value of x4, that is 10, is again greater than this one? Yes. Now expected value of x3 is again greater than this. Yes, correct. So what about the other thing? Firstly they have said that expected value of x1 is less than x5. Now this is wrong. What about this one? Again this is wrong. So next, what about the variance? So for the variance, we'll have to remember that the value of PDF at mean, meaning that the height of this peak, this is inversely proportional to the standard deviation, right? So what does that mean? It means that more the peak, less is the variation, right? So how is that? How are we getting that? So we have that, let's say the peak of x1 and x2 is approximately same, right? So this is true. And now what about this one? This is it means that the variance of these two distribution is less. So again, which is greater than this? x3, right? So x3 is again, the peak is smaller than these two. It means that the variation is larger than these two values. Yes, this is also true. And now what about x4? x4 again, yes, it is true, which is greater than x3 and which is greater than x5. Okay. What about this one? x1, is it less than x3? x3 is here, x1 is here. Yes, so the variance of x1 is less than variance of x3. And what about x4? x4 is here, again that is true. What about x5? Again these two options are true. Next question. So they have given a function, and what do we have to find out? We have to find out the variance of this particular distribution. Okay, so what is the formula for variance? Variance of any random variable x is nothing but expectation of x square minus expectation of x the whole square. Okay, how to find out the expectation of x? That is nothing but integral s fx of x dx. Okay, so which is nothing but the given interval is 0 to 1, 0 to 1 x into 4x cube dx. So which is nothing but integral 0 to 1 4x to the power of 4, which is nothing but 4 by 5 x to the power of 5, 0 to 1, so which is nothing but 4 by 5. Okay, so now what is the expected value of x square, which is nothing but integral x square fx of x dx. So which is nothing but integral 0 to 1 x square into 4x cube dx. So which is nothing but 4 divided by 6 into x to the power of 6, 0 to 1. So which is nothing but 4 by 6, that is nothing but 2 by 3. And now what is the variance now? Variance of x is nothing but 2 by 3 minus 4 by 5 the whole square, which is nothing but 2 by 3 minus 16 by 25, which equal to 75, 50 minus 48, which is equal to 2 by 75. Okay, next question. So we have a uniform distribution of x given as uniform a1 comma b1, and y is uniform of a2 comma b2. Based on this information, choose the correct options from the below. Okay, so now what is the expected value of x? Expected value of x is nothing but a1 plus b1 whole divided by 2 And what about variance of x? Variance of x is nothing but b1 minus a1 the whole square whole divided by 12. Okay, so similarly, what about expected value of y is nothing but a2 plus b2 whole divided by 2. Now what about variance of y? This is nothing but b2 minus a2 whole square whole divided by 12. Now looking at the options first, let's consider these things. So if expected value of x is equal to expected value of y, it means that a1 plus b1 whole divided by 2 is equal to a2 plus b2 whole divided by 2. 2 will be cancelled. It means that a1 plus b1 is equal to a2 plus b2, and this can be written in terms of, and I'll send a2 to the LHS, that is a1 minus a2 is equal to b2 minus b1. So this option is right. So what about if the variance is equal? If the variance of x is equal to variance of y, what will happen? So we'll have b1 minus a1 the whole square divided by 12 is equal to b2 minus a2 whole square divided by 12. Firstly 12 will be cancelled. If I take the square root on both sides, I'll have b1 minus a1 is equal to b2 minus a2. Okay, so looking at this, none of the option will hold true, right? So only the last option is correct. Next one, they have given a CDF and we have to find out the PDF of this particular variable. So how to do this? We simply have to differentiate all of the functions involved, right? So fx of x is nothing but differentiation of fx of x. So that is nothing but differentiation of 0 and differentiation of x by ln 4 and differentiation of 1 minus e to the power minus x, and the ranges are same: x lesser than 0, 0 less than or equal to x, and less than or equal to ln 2, and ln 2 less than or equal to x, and less than infinity. Now what is the differentiation here? So that is nothing but differentiation of a constant is 0, and now differentiation of x by ln 4. Ln 4 is a constant which will be outside, and what is the differentiation of x? That is nothing but 1. That is 1 by ln 4. Now what about this guy? Differentiation of 1 is 0. Differentiation of minus e to the power of minus x is minus e to the power of minus x into minus 1, that is e to the power of minus x. This is the PDF of the particular given random variable. Okay, thank you for watching. Hope that was helpful. See you guys in the next video. Consider like, sharing and subscribing.